Hello, so I'm going to be working with Honors Algebra 2, Unit 1, Topic 3. So looking at number 1, look at the table of values for the two functions of f and g below. So keep in mind that when I'm talking about x and f of x, that is really saying that that's the y value. That is also the y value. So it says the possible answers are in the expressions box to the right. So the thing that I notice about this first kind of table, I looked that the x values are not necessarily going up by 1. They're going up by a multiplication of 10. Right? So if I say multiplying by 10, multiplying by 10, and then the other one is going up by adding by 1, adding by 1. And if I know anything about exponential functions, right, it is not the x values that go up by tens, right? It most likely is dealing with some type of logarithmic equation. And most likely, since we are going up by tens each time, it is going to be log base 10 of x. Now, it's kind of funny that they use log base 10, which is also just the same as log of x. So that means that if you are using, let's say, your calculator for the progress check, which you can, if you type in log of 10, you should end up getting the value 1. If you type in log of 100, you should get 2. Now g of x, now I can see that each one of these are going up by 1 each time. So if those are going up by 1 each time, right, that means I'm plugging in an x value. So if I'm plugging in an x value, and I can see that these are going up by multiples of 2, that is going to be an exponential growth. So that would be 2 to the x. Okay, so the key thing to look for is which values are being multiplied. If the x value is being multiplied by some type of value, it is going to be some type of logarithmic expression, or logarithmic equation, I should say. And if the y value is being multiplied by the same value each time, it is going to be some type of exponential function. Okay, it says below are the key features of a graph of a function g that is a transformation of the function f of x is equal to log base 2 of x. So the domain is 3, greater than 3. The range is all real numbers. The function g is decreasing on the interval, so from 3 to infinity. So the equation of the asymptote is that x is equal to 3, and the x-intercept is at 4. So describe the transformations for this. So a couple things. I'm going to try and draw this to kind of help you along with this. Now, normally, the log base 2 of x, the graph ends up looking something like this. Okay, so we have an intercept that is going to be at 1, 0. We know that there is going to be a vertical asymptote at x is equal to 0. So a couple things to kind of note. So the asymptote is 3. So that means that this new graph is going to be not just at 0, but 1, 2, 3, 3 units over. So which means that that intercept is actually going to be right there. Now, a couple things to also take note. It's saying it's decreasing on the interval from 3 to infinity. So it means that it's going to be going down like this. And I'm sure it seems like that follows all the other stuff. So the domain is greater than 3. The range is all real numbers, which most logarithmic graphs are. The function is decreasing on an interval from 3 to infinity. The equation of the asymptote is that x is equal to 3, which that is also true. And then the x-intercept is at 4, which, yet again, if I move it 3 units to the right, it will give us the intercept being at 4. So to describe the transformations of the resulting of the graph of g, so I can say that it is going to be translated 3 units to the right. And then since we are, in a sense, going from an increasing graph to a decreasing graph, it is going to be reflected over the x-axis. So how do I write this specific rule? Since we're talking about a translation to the right, that means that we are going to be working with inside the parentheses, so that would be f of x minus 3, so that moves it 3 units to the right. And since we're also talking about a reflection over the x-axis, which means that we're going to, in a sense, be changing the f of x to be negative. So how to do that? We're going to write this as negative log base 2 of parentheses x minus 3. And that will give us a result. The negative, what it does is it reflects over the x-axis, and then the minus 3 moves it over 3 units to the right. So fill in the blanks of the statements below. Use the word bank. So it says the transformations of the product of g of x is equal to 2 to the 3x minus 4 from f of x is equal to 2 to the x. So the dilations by a factor of blank with respect to the blank in a translation of blank units blank. So I'm going to work with the minus 4 first. So translation of 4 units, so that'll be 4 units. And then since it's minus, it is going to be down. So we're probably not going to be using those two again. Now, this 3 right here, since it is tied in with, in a sense, the parentheses, it would end up being 3x right there. So this is going to be changing something horizontally. Okay, so it is going to be changing horizontally. Now, when we would be multiplying by a value that would be in front, so let's say that this was, let's say, a. So if we're multiplying that this changes it vertically, and it's going to be some type of stretch, right? If it is greater than 1, but if it's between 0 and 1, then it's going to be a shrink, right? We kind of talked about that a little bit before, but now they say a dilation by a factor. So since it is inside the parentheses, it's actually the reciprocal of what we would think. So instead of being 3, it is actually going to be 1/3 with respect to, and since the a value is acting as the vertical, which is also known as the y-axis, this is going to be affected by the x-axis. So this is going to be x-axis. Unit 4 and 5, for items 4 and 5, solve each equation for t. Show the work that leads you to your solution. Your solution may be exact or correct to at least 2 decimal places after the decimal point. Two places after a decimal point, which means rounding it 2 decimal places. So the first thing I'm going to do, divide both sides by 3. I'm going to try and do this without a calculator as best as I can. So I end up getting 200. Now, to, in a sense, bring down this exponent, I have this 10 to work with. So how do I get rid of a base 10? And to get rid of a base 10 and bringing down the exponent, the 2t, I have to do log base 10 to both sides. So I'm going to write log base 10 of 10 to the 2t is equal to log base 10 of 200. Now that can get me some type of decimal, right? It's not going to work out perfectly because 10 to something to some power or to some exponent is not going to give me 200, so I can't evaluate that. These in a sense cancel out, so I'm left with 2t is equal to log base 10 of 200, and then divide both sides by 2. So t is going to be equal to log, since it's actually base 10, I'm not even going to actually write the little 10, so I'm going to write down log of 200 over 2 is our answer. Now the important fact to kind of keep in mind as well, see this 200 and see this 2. It's very tempting on saying let's divide both sides by, let's divide the 200 by 2 and get 100, but since it's actually logged into the parentheses, you need to do the log first before you actually divide by 2. So this will end up giving you some type of answer. You can type that into your calculator. Just keep in mind that the 200 is locked inside the parentheses and cannot get out unless if you evaluate it. Okay, the next one, number 5. So I'm going to combine like terms. So the combined like terms, so that one and that one, since they both have an e to the 4t. And then the other two, the 200 and the 1500. So I'm going to end up getting 5e to the 4t is equal to, right, because I subtracted 2e to the 4t to both sides, and then subtracting 200, so that's going to give us 1300. Let's get rid of the 5. E to the 4t equals, so that's just going to be 260. I think that's right. Should be okay. Yep. So to get rid of e, we do ln to both sides. So we're going to do ln. So that means that we're saying ln of 260. So we end up getting 4t is equal to ln of 260. Divide both sides by 4. And we get t is equal to ln of 260 divided by 4. That's going to be my answer right there. Okay, so it says a power in megawatts that a power plant produces X hours after midnight on a hot summer day is given by the exponential function, which is that fancy equation. So what is the average change in megawatts per hour from the time from time interval 4 to 12 and then show your answer. So I'm going to make a mark at 4 and I'm going to make a mark at 12. So what I'm trying to do is I'm trying to find the rate of change. So now what I'm doing here is I'm drawing a terrible line, which did not work out well. So I'm drawing a line that looks like that. That's much better. And trying to figure out how much did this change. Now, kind of ironically, I could actually just count up units and look at the graph, but let's say that you didn't have the graph available to you. What we want to do is we want to plug in 4 into that equation. So we want to say f of 4 is equal to 10 times 2 to the 4 over 4, which ends up giving us, and in this case, this is going to give us 20. F of 12, 10 times 2 to the 12 over 4, which is going to end up giving us 80. And then whenever you see average rate of change, that really just means slope. So if I'm trying to figure out an average rate of change, that is y2 minus y1 over x2 minus x1. And so I'm going to write this as 80 minus 20 divided by 12 minus 4, right? Because I can treat this as x1 and y1. I can treat this as x2 and y2. So 80 minus 20 gives me 60, and then 12 minus 4, which gives me 8. So cut that in half, 30, cut in half again, then cut it in half once more, so it's going to give us 7.5. And how I would write this, it would be megawatts per hour. So 7.5 megawatts per hour. Okay, so another power plant product, X hours after midnight, is modeled by that specific function. At what time is the power production of both plants the same? So explain how you determined your answer. So since we actually have both of the two equations, right, we can actually graph both of these and then just set them equal to one another. Okay, so I'm going to use Desmos, but you can use your calculator to kind of help you along. The more important part here is making sure that your window is set up correctly. So I'm going to say y is equal to 10 parentheses 2 to the, go and write this, x divided by 4. And make sure that your exponent is also set correctly, that you need to make sure that you include parentheses. And then y is equal to 30 parentheses 8 divided by 3. Close parentheses, raised to the x divided by 12. All right, so taking a look at these, I can see that both of them intersect right at this specific point. So we're going to say at 12 hours, that is going to be 80 megawatts. Okay, so at what time is the power production of both plants the same? So that would be at 12 hours, and that is by doing the intersection of both graphs. Now, most likely you're probably not going to have to be able to do this by hand, but if you were, you would actually end up saying both of these equal to one another and do some calculations. Yet again, kind of difficult to do, but for the most part, it isn't terrible. But you are going to be able to have a graphing calculator, so just graph it in and find the intersection. Okay, so I do have to excuse me and my cold. So the following problem is using Newton's law of cooling. So T of lowercase t represents the temperature at the time t. T of A is the temperature of the surrounding room. T of 0 is the initial temperature of the object that is cooling, and K is our constant. So the difficult part with these specific problems is finding the K value, but if they actually give you the K value, it is super easy. So Jackie brings a bottle of juice home from the market. She would like to have a cold glass of juice, but doesn't want to put ice in her glass because, it'll water it down. She decides to cool it quickly by putting the juice in the freezer. The initial temperature is 73 degrees, which is most likely your room temperature, but then she wants the temperature of, and the temperature of the freezer is 4 degrees. The decay constant is 0.05. So let's write down a couple things, and actually it's kind of nice that it's already set up for us, so I'll just write down those values. So this will be 0.05 for exponential for our decay constant. So the initial temperature of the object that is cooling. So the initial temperature, which that would be 73 degrees. We're also talking about Fahrenheit. T of A is the temperature of the surrounding air. So when she places it into the freezer, that would be 4 degrees. And then T of T represents the temperature at that specific time T. Since I'm not necessarily given a specific time, I'm just going to actually just fill in our values. So T of A, which will be 4, plus T of 0, which is 73, minus T of A, which is also 4 again. Then e to the negative 0.05, and then T. Just like that. Okay, so it says, was the temperature of the juice 9 minutes after she puts it in the freezer? So we're going to do T of 9. And if we're talking about 9 minutes, I think we can also kind of say that, assume that T is going to be 9. So we'll say T is going to be in terms of minutes. So T of 9 is going to be equal to 4 plus 73 minus 4 e to the negative 0.05, and then change this to be 9. Okay, so I can just type this into my calculator. I'm going to type this into Desmos because, well, Desmos is also a calculator too. And yes, you can also graph this and call this a day. So I'm going to type in 4 plus parentheses 73 minus 4, and then close parentheses, e to the parentheses. And then remember, this is also going to be negative, so I'm going to say negative 0.05 times 9, which ends up giving me, so T of 9 equals 47.996. Let's round 3 decimal places, that's fine. Show how you got determined your answer. Okay, so we're most likely going to say right around, I'd say we can round this up to be 48 minutes. Excuse me, 48, not minutes, so 48 degrees Fahrenheit at 9 minutes. All right, and that concludes Honors Algebra 2, Unit 1, Topic 3. If you have any questions, please feel free to comment on my Discord or message me in relationship, or comment down below, and I'll be more than happy to explain any other types of things. Thanks.